In the first part of this video, we saw that the origin of the Sun's future light cone would be a negative curvature of space, which would hold time in our future. As the future does not exist, because it has not yet happened, this would have resulted in an apparent reversal of the arrow of time. That is, what exists must be in our past. Even assuming an imaginary orientation in both cases, the arrow of time would stop pointing to the future and would start pointing to our past. So, let's try to adapt the physicist's future light cone to this reversal of the direction of the arrow of time. According to Hawking, the Earth would be traveling in space outside the Sun's cone, and therefore towards the future. In the case of the sudden death of the star, no future light cone would remain, except in our imagination, as the Sun would continue to shine in the sky for 8 minutes. This problem would involve the observer, because for his viewpoint, everything that exists would already be in his past. This would attribute instantaneity to the Sun's death, even if it had taken place 8 minutes ago. The notion of the Sun's future light cone exists by similarity with the observer's notion of the past light cone. The speed of light is measured by remote tracking in the only direction of the arrow of time in which this becomes possible. That is, towards the observer's past. The 8 minutes away from our star are indirectly determined using the speed of light. Then, the arrow of time is inverted, and the concept of light come from the past is extrapolated towards our future. The future is normally considered, by science, as an inverse image of what we see in our past. This problem would be created by the polarization of light, which takes no time. The future does not exist, in practice, because it has not yet happened. The arrow of time would have a negative orientation in that sense, following the formation of the curvature of space. It can be said that the observer would contain time by a principle of exclusion of access to what would be happening in his future. These past and future light cone models are suggested by the light emitted by the stars, not by space. Although imaginary, they would be right cones. That is, they would result from the rotation of a right triangle on one of its legs. To obtain an ellipse, and not a perfect circle, this straight cone would have to be cut across. If we don't, the planet's orbits will be circular, not elliptical, as this will be the information that will be made available to the observer by polarized light. The image of the Sun, which we see 8 minutes late, would always retain the same volume and brightness over time. This is due to the virtual leveling off between ultraviolet and infrared. Thus, Jupiter should receive, proportionately, less light from the Sun than Earth does, as it is much further away from the source. However, the Voyager spacecraft have revealed that Jupiter, like Saturn, reflects up to 3 times more light into space than that received from the Sun. Without knowing the cause of the problem, the physicists concluded that the mentioned planets must have an internal source of heat. There would be a way out of this problem. We said earlier that even if space were to curve, it would remain virtually flat, because it would be described by its messenger and not by itself. Thus, if the curvature of space varied, more or less, it would influence the density of the Sun, without this implying a change in its total mass. If space curved more sharply around the star, its density would increase. the star's total volume should decrease, emitting less light into space. With the transient variation of the intensity of its brightness, the sun would no longer act as if it were a lamp of constant brightness. An orbiting planet should respond, secondarily, to the increased curvature of space, moving closer to the star. Meanwhile, it should receive less sunlight than usual. If the opposite occurred, and space curved less around the star, there would be an increase in its volume and a decrease in the density of its mass. Under these conditions, the sun should radiate more light and heat into space. The Earth, in orbit, should respond to the lesser curvature of space by moving away from the star, receiving more light and heat than it normally receives. This removal of the planet in the direction of aphelion would occur without it abandoning, in an absolute way, its physical position in space. In other words, the veiled action of space is what governs the relative movement in space-time. It is said to be veiled because the stretching of space would contract time, and, without time, there would be no movement that could be measured. The distance or approach between the star and its planets would not be absolute. It would derive from the elasticity of the space around them. In the case of Jupiter and Saturn, they could be receiving more light and heat from the Sun than would normally be expected. According to a comment by Einstein on Newton's absolute space, which appears in his book, How I See the World, space would be capable of generating inertia without depending on the direct influence of masses. The contraction of time in our future would justify the thought that, even if light took time to communicate the event of a star's gravity, it would present itself to our senses as if it had occurred instantaneously. It would not matter how long it took for the light of a distant star to reach us on Earth, as the star would only be seen after its light was already here. Without the presence of light, the stars would cease to exist for us, even if they were still there. It can be seen that this would be a problem related only to our memory, as the universe does not seem to be very concerned with what we think about it.